Need extra money for college? ISL Education Lending Scholarship Program provides $1,000 for college expenses. Registration is easy and no essay is required. Visit www.iowastudentloan.org/register to learn more. The scholarship is open to Iowa residents who are in high school and college students, as well as parents of those students. Register by November 30th for your chance at one of the 45 awards at www.iowastudentloan.org/register.
This is SpaceTime Series 23, Episode 100, for broadcast on the 25th of September 2020. Coming up on SpaceTime, Solar Cycle 25 now formally underway, the asteroid Bennu ejecting particles into space, and another near miss for the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have determined that our local star, the Sun, has now formally moved into a new solar cycle, which will peak in a new solar maximum in 2025. Measurements indicate that the solar minimum between the last solar cycle 24 and the new solar cycle 25, period when the Sun is least active, happened back in December 2019, when the 13-month smooth sunspot number fell to just 1.8, according to the Solar Cycle 25 prediction panel chaired by NASA and NOAA, the National Oceanographic and Atmospheric Administration. The delay in identification happens because the Sun's quite variable, and so can take many months after the fact to declare the event. Scientists use sunspots to track solar cycle progress. The dark blotches on the Sun's surface are associated with solar activity. They're located where magnetic field lines enter and leave the Sun's visible surface, resulting in areas of slightly lower temperature than surrounding regions. These are also often the points of origin for massive explosions, such as solar flares or coronal mass ejections, which can blow huge amounts of energy and solar material into space. If this material crashes into the Earth, it can trigger geomagnetic storms, also known as space weather or solar storms. And they become a problem, because while they provide the spectacular light show known as the Aurora Australis and Aurora Borealis, the southern and northern lights, they also increase radiation exposure for astronauts, damage delicate electronics aboard spacecraft, interfere with communications and navigation systems, cause power blackouts to energy grids on the ground, and they can affect the lifespan of orbiting spacecraft by causing the atmosphere to expand and contract, increasing atmospheric drag and therefore orbital decay, forcing spacecraft to use up more fuel in order to maintain their correct position. To determine the start of the new solar cycle, the prediction panel consulted monthly data on sunspots from the World Data Centre located at the Royal Observatory of Belgium in Brussels, which tracks sunspots and pinpoints the solar cycle's highs and lows. The data suggests that solar cycle 24 was pretty average in length at around 11 years, and it had the fourth smallest intensity since regular record-keeping began with solar cycle 1 back in 1755. It was also the weakest solar cycle in 100 years. Solar maximum occurred back in April 2014, when sunspots peaked at 114 for the solar cycle, well below the average of 179. Solar cycle 24's progression was unusual. The Sun's northern hemisphere led the sunspot cycle, peaking over 2 years ahead of the southern hemisphere's sunspot peak, and this resulted in solar maximum having fewer sunspots than if the two hemispheres were in phase. For the past 8 months, activity on the Sun has been steadily increasing, a clear indication that we've transitioned to solar cycle 25. As for the future, well, solar cycle 25 is forecast to be fairly weak, similar in strength to cycle 24. Solar max should happen around July 2025, with a peak of around 115 sunspots. How quickly solar activity rises is an indicator for how strong the solar cycle will be. And although there's been a steady increase in sunspot activity this year, it has been fairly slow. The Solar Cycle 25 prediction panel believes the new cycle will break the trend of weakening solar activity seen over the past 4 cycles. And so there's no suggestion of a Maunder minimum in solar activity as climate change deniers have been claiming. The Maunder minimum was an unusually deep solar minimum around 1645 to 1715, during which sunspots became exceedingly rare. It roughly coincided with the middle part of the Little Ice Age, during which Europe and North America experienced cooler than average temperatures. But whether there's a causal relationship is still under investigation. You see, the drop in global average temperatures in paleoclimate reconstructions at the start of the Little Ice Age was between about 1560 and 1600, whereas the Maunder minimum began almost 50 years later. And the Northern Hemisphere temperatures during the Maunder minimum weren't significantly different from the previous 80 years. And all that suggests that any decline in solar activity was not the main causal driver of the Little Ice Age. In fact, the current best hypothesis to explain the Little Ice Age is that it was caused by increased volcanic activity. Solar cycle prediction gives a rough idea of the frequency of space weather storms of all types, from radio blackouts to geomagnetic storms and solar radiation events. It's used by many industries to gauge the potential impact of space weather on their operations in coming years. In 2024, before the peak of sunspot activity in Solar Cycle 25, NOAA is slated to launch a new spacecraft dedicated to operational space weather forecasting. NOAA's Space Weather Follow-on L1 Observatory will be equipped with instruments to sample the solar wind, provide imagery of coronal mass ejections, and monitor other extreme activity on the Sun in finer detail than before. NOAA's next geostationary operational environmental satellite, GOES-U, is also slated for launch in 2024. GOES-U will carry 3 solar monitoring instruments, including the first compact chronograph, which will help detect coronal mass ejections. And of course, another big event scheduled for 2024 will be the Artemis 3 mission, returning humans to the surface of the Moon. So it's important to keep tabs on the Sun's solar activity. This report from NASA TV.
There's a rhythm emanating from the Sun to the edges of the solar system. Roughly every 11 years, our star ramps up to a turbulent state, expelling violent eruptions. After a peak, it calms down to a quieter phase before starting all over again. This is known as the solar cycle. This ebb and flow of solar activity affects the entire solar system, including spacecraft electronics and astronauts that can be affected by particle radiation if they're not sufficiently protected. Understanding the solar cycle is one of the oldest problems in solar physics, and now predicting it is more critical than ever as we venture to the Moon, Mars, and beyond. So here are ways we've learned about tracking it.
So welcome to the dome. Today we're gonna observe the Sun and see if it has some sunspots.
Every morning when the skies are clear, Olivier looks through this telescope in search of sunspots. These are dark blotches on the Sun that are the main source of solar eruptions. They appear and disappear on the Sun's surface. Olivier and a team of sun observers record the pattern of sunspots by pencil. The first known record of sunspots date back to around 1,000 years ago in China. After the invention of the telescope in the 17th century, routine observations were made. Today, sunspot drawers still use the same technique. While we've created satellites that can see the Sun in much more detail in recent decades, drawing by hand keeps the centuries-long record consistent. The sunspot number record goes back farther than any other instrument, allowing scientists to analyze the Sun's behavior over many, many solar cycles. Sunspot numbers are collected from observatories around the world and are averaged. During every 11-year cycle, the number of sunspots rise from 0 to a peak and then go back down to 0 again. Scientists use these numbers to determine when a new solar cycle begins and how active a cycle is. Solar maximum, the period of highest activity, can vary wildly from cycle to cycle. The more sunspots there are, the higher the frequency of solar storms of all types. Some that create aurora, and some that can affect power grids on Earth. But sunspot number isn't the only indicator we see. These numbers are often combined with other signs. At the beginning of each cycle, sunspots appear on the Sun in the mid-latitudes for a brief few hours to days. At solar minimum, there are often days without any spots at all. As the Sun becomes more active, sunspots form closer to the equator and can stick around for weeks to months. These sunspot patterns give clues to what drives the solar cycle, the twisting of the Sun's magnetic field. Like Earth, the Sun has a magnetic field with a north and south pole. But unlike Earth, the Sun's magnetic field becomes extremely complex. This is because the Sun is made of plasma, a charged gas that generates electric currents. As the Sun rotates, plasma around the equator moves faster than near the poles, causing the magnetic fields to become stretched, elongated, and then twisted. Then kinks in the magnetic fields burst through the surface as sunspots larger than the size of Earth. As the solar cycle unfolds, more sunspots appear and the magnetic field becomes more tangled. At the peak of the solar cycle, the sun's magnetic field flips. The North Pole switches to the south and vice versa. The cycle then ramps down, ready to start a new cycle. Scientists can eventually see the result of this flip inside sunspots using satellites. Most sunspots appear in pairs. Like a magnet, one side is positive and the other is negative. After they form, they gradually disappear again, leaving behind remnants of magnetic fields that move towards the sun's poles. Eventually, each pole accumulates enough magnetic fields, forcing the sun's poles to flip at the peak of the cycle. Then, new sunspot groups appear with the polarities in the opposite direction. Scientists look for a consistent string of these new sunspots in order to declare the next solar cycle. But the transition between cycles is slow and messy. Cycles often overlap, creating freckles of old and new sunspots on the sun at the same time. Scientists can only determine we're in the new cycle when the number of new sunspots overtake old ones, which can be 6 months to a year after the new cycle has begun. While these spots give us a visible tracker, in recent years, scientists have discovered another signal that's hard to see from Earth. The strength of the sun's poles during solar minimum can help predict how active the next cycle will be. After the poles have reversed at the peak, scientists keep a close eye on it for the next few years. If the magnetic fields accumulated at the poles become strong during this time, it's likely the next solar cycle will be an active one. If the buildup is weak, the next solar cycle won't be as active. While we use these indicators to track the sun, predictions are still hard. After all, we've only had detailed satellite observations of the last 4 solar cycles, and scientists are still learning about what causes the sun's cycle. So until we piece together those missing pieces, the sun, even with its 11-year clock, will continue to surprise us.
This is SpaceTime. Still to come, the asteroid Bennu ejecting particles into space, and the Sentinel 6A spacecraft getting ready for launch. All that and more coming up on SpaceTime.
Need extra money for college? ISL Education Lending Scholarship Program provides $1,000 for college expenses. Registration is easy and no essay is required. Visit www.iowastudentloan.org/register to learn more. The scholarship is open to Iowa residents who are in high school and college students, as well as parents of those students. Register by November 30th for your chance at one of the 45 awards at www.iowastudentloan.org/register.
Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today. And find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
When NASA's OSIRIS-REx spacecraft arrived at the asteroid Bennu, mission scientists pretty quickly realized that they were orbiting something rather strange. Certainly a lot stranger than they had expected. Not only was the boulder-strewn asteroid shaped like a rough diamond, its surface was literally crackling with activity. It was shedding or spitting small pieces of rock into space. Astronomers refer to this as dynamic particle ejection events. Now, after orbiting the 565-metre-wide space rock for more than a year and a half, scientists think they've finally worked out what's going on. The findings, reported in a series of articles in a special edition of the journal Geophysical Research, provides a detailed look at how these particles act when they're in space, possible clues as to how they're ejected in the first place, and it even examines how their trajectories can be used to approximate Bennu's weak gravitational field. Astronomers usually consider comets as the celestial objects in our solar system most likely to actively eject material. Of course, comets are composed of ice, rock and dust. As these ices are heated by the sun, the vapour fizzes from the surface. Dust and chunks of the comet's nucleus are flung off, forming the comet's coma and long dusty tails. Asteroids, on the other hand, are composed mainly of rock and dust, with perhaps only small quantities of ice. But it turns out some of these space rocks can be surprisingly active. There are, of course, the so-called rock comets, asteroids which swing by the sun on comet-like orbits, getting hot enough to crack rocks on the surface, releasing energy in the process which then flings these rocks into space. It turns out most rock comets actually started out as regular comets, but then lost so much of their ices they eventually simply became asteroids. In this study of the asteroid Bennu, OSIRIS-REx lead scientist Dante Loretta from the University of Arizona says while the boulder-strewn surface of the asteroid was always thought to be the wildcard discovery, the fact that particles are also flinging off the asteroid has provided more surprises. Loretta and colleagues have spent the last year investigating Bennu's active surface. Cameras on OSIRIS-REx spotted rock particles being repeatedly launched into space during a January 2019 survey of the asteroid. Now, most of these pebble-sized rocks, typically measuring around 7 millimetres in diameter, would typically fall back onto Bennu's surface under the asteroid's weak gravity, sometimes even ricocheting back up into space after colliding with the surface. For most pebbles, it was just a short hop, but others took longer to return to the surface, remaining in orbit for a few days and up to 16 revolutions. And then there were some which were ejected with enough oomph, I think that's a scientific term, to completely escape from Bennu, forming tiny micrometeoroids floating through space. By tracking the journeys of hundreds of ejected particles, the authors determined that thermal fracturing, just like we see on rock comets, was taking place on Bennu's surface. It was happening as the asteroid would be repeatedly heated and cooled as it rotates. But interestingly, they also found the locations of ejection events matched impact locations where meteoroids were hitting the surface of Bennu as it orbits the Sun. The authors now think it might even be a combination of these two phenomena, although more observations are needed. Meanwhile, the authors were able to use these particles ejecting off the surface and then falling back down again as high-fidelity probes of Bennu's gravitational field. See, many of these particles are orbiting Bennu far closer than what will be safe for the spacecraft, and so their trajectories were highly sensitive to the irregular gravity of Bennu. And this allowed the authors to estimate Bennu's gravity even more precisely than what was possible with OSIRIS-REx's instruments. On average, only 1 or 2 particles are ejected each day, and because they're in a very low-gravity environment, most are moving fairly slowly. That means they pose little threat to OSIRIS-REx, which will attempt to briefly touch down on the asteroid surface next month in order to scoop up some surface material for the sample return portion of its mission. And that material may even include particles that had been ejected into space before dropping back down onto the surface. If all goes as planned, OSIRIS-REx will return to Earth in September 2023 with a cache of Bennu material ready for scientists to study in detail. This is SpaceTime. Still to come, Sentinel 6A getting ready for launch, and another near miss for the International Space Station. All that and more still to come on SpaceTime. Records show that, on average, global sea levels have risen by 3.2 millimetres per year between 1993 and 2018 due to global warming. But hidden within this average is the fact that the rate of sea level rise has actually been accelerating over the past few years. So, taking measurements of the height of the sea surface is essential to monitoring this worrying trend. And that's where the twin satellites of the Sentinel-6 mission will come in. The first of the joint NASA and European Space Agency Copernicus spacecraft are slated to launch in November aboard a Falcon 9 rocket from Space Launch Complex 4E at the Vandenberg Air Force Base in California. Together with its twin spacecraft Sentinel-6B, which will launch in 2026, the 1,440-kilogram Sentinel-6A will measure the oceans with extreme precision, covering 95% of the planet's oceans every 10 days from its 1,336-kilometre high orbit. The probe's equipped with Poseidon 4 synthetic aperture radar altimeter for topographic ocean measurements. And there's also a multi-frequency microwave radiometer to study the total water vapor column content of the atmosphere. The Sentinel-6 twins will join the Topex Poseidon and Jason series of satellites, which have been gathering precise sea level measurements for nearly 3 decades. But while the Sentinel-6's primary focus will be on monitoring sea level rise due to global warming, they'll also provide atmospheric data that will improve weather forecasting, help track cyclones, hurricanes and typhoons, and improve climate models. The two probes will peer deep into Earth's atmosphere with what's called Global Navigation Satellite System radio occultation. This will allow them to collect highly accurate global temperature and humidity information by tracking radio signals from navigation satellites to measure the physical properties of Earth's atmosphere. See, as a radio signal passes through the atmosphere, it slows, its frequency changes, and its path bends. Called refraction, this effect can be used to measure minute changes in the atmosphere's physical properties, such as density, temperature, and moisture content. And this will improve weather forecasting, providing data on long-term atmospheric changes caused by global warming. This report from NASA TV.
Sentinel-6 microfrylake will provide important information in producing our daily weather forecast. So how does this work? The data from the GNSS-RO, that stands for Global Navigation Satellite System and Radio Occultation, the new instrument on board, is ingested into the weather models that can help us with our weather forecasting and our warnings to help protect the public.
This mission will use a special technique called radio occultation, which measures tiny changes in the radio signals broadcast by GPS and other navigation satellites. The GNSS-RO instrument essentially measures the time delay of the radio signals as it goes through different layers of the atmosphere. So this allows us to unravel the temperature and moisture content of the atmosphere layer by layer.
Most of the weather that we experience comes from our west over the ocean that lacks conventional observations like what we have over land. The GNSS-RO will help address these challenges by providing us very important temperature and moisture information over the ocean that will help our forecast here on the West Coast.
Studying the entire atmosphere, from the surface all the way up to the stratosphere, is important for us to improve our understanding of our weather and climate change.
We're very excited with the data that the GNSS-RO will provide for these weather models that will ultimately help improve our forecasts and warnings to help protect the public.
And that report from NASA TV featured meteorologist Mark Jackson from the United States National Weather Service and instrument scientist Chai Ao from NASA's Jet Propulsion Laboratory in Pasadena, California. This is SpaceTime. Still to come. Space junk triggers another emergency avoidance maneuver for the International Space Station. And later in the science report, Arctic wildfires pump a record 244 megatonnes of carbon dioxide into the atmosphere. All that and more still to come on SpaceTime. The International Space Station's been acting more like a dodgem car in recent weeks, undertaking several debris avoidance manoeuvres in order to keep clear of orbiting space junk. Debris avoidance manoeuvres are undertaken using orbital maneuvering engines on the Russian segment of the orbiting outpost. And these manoeuvres are becoming a regular occurrence as Earth's near-space environment gets more and more crowded. The latest incidents include one involving the remains of a booster stage of a Proton K rocket, which originally launched a Soviet-era spacecraft back in 1987. That was followed by another manoeuvre to avoid the American BRICSat-2 experimental amateur radio satellite, which was launched by SpaceX last year. The Russian Federal Space Agency Roscosmos has repeatedly warned its space station partners about the growing threats being posed by disused spacecraft, spent rocket stages, and other space junk. It's now calling for new regulations to deal with the problem and the threat being posed by new mega constellations like SpaceX's Starlink. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a Science Report. A new study has confirmed that the wildfires which scorched the Arctic tundra this year pumped a record 244 megatonnes of carbon dioxide into the atmosphere. The findings, reported in the journal Nature, show that the carbon dioxide release is a dramatic 35% more than last year's record-breaking output. Scientists say the dramatic increase in Arctic wildfire severity was caused because they're torching peatlands, which have been accumulating carbon for many millennia, making them the most carbon-dense ecosystem on the planet. The authors describe the fires as part of a vicious cycle. Their emissions fuel global warming, which in turn causes more fires, which then releases even more carbon. As if being unpopular at 13 wasn't heartbreaking enough, now new Swedish research suggests that being unpopular at this age could also end up affecting your heart in later life. A report in the British Medical Journal looked at the health of more than 10,000 men and women whose popularity among their peers was known at the age of 13 and have now been tracked into their 60s. The study found that people marginalised by their peer group at age 13 had a 33 to 34% higher risk of circulatory disease in adulthood. The authors say peer relationships play an important role in children's emotional and social development and may have considerable long-term implications on health. Ethiopian scientists have found that kids who live at high altitudes are born shorter and grow more slowly than kids who live closer to sea level. A report in the Journal of the American Medical Association analysed 133 demographic and health surveys from 59 low and middle income countries, including height records for nearly 1 million people living at altitudes ranging from 372 to 5,951 metres above sea level. They found that kids living 1,500 metres above sea level or higher were born shorter and grew more slowly than kids who lived at lower altitudes. Well, we're all used to being checked out by seagulls looking for a quick feed. But a new study has shown that at least one type of seagull, known as a herring gull, notices not just the approaching humans and what they're eating, but also where they're looking. And the gulls will tend to scamper away sooner if they know they're being watched. Researchers from the University of Exeter approached a bunch of gulls while either looking at the ground or looking directly at the birds. They found that gulls were slower to move away when not being watched, allowing humans to get on average 2 metres closer. The study also showed that newly fledged gulls were just as likely to react to human gaze direction as older birds, suggesting they're either born with this tendency or they learn it quickly. Researchers were also able to confirm the widely held view that urban gulls are far bolder than their rural counterparts, letting a person get on average 2.5 metres closer before walking or flying away. A total of 155 gulls were involved in the study, including 50 adults and 45 juveniles in urban settings, and 34 adults and 26 juveniles from rural settings. As well as being quicker to scamper away, rural gulls were also more than 3 times as likely to fly rather than simply walk, suggesting they're generally less used to being approached. The Mandela effect is the unusual phenomenon in which a large group of people remember something that never actually happened. This form of collective misremembering of common events or details first emerged back in 2010, when countless people remembered the death and funeral of Nelson Mandela. They recalled how sad they felt when they heard the news that he had died in his remote island prison during the 1980s. Of course, in reality, Mandela was freed in 1990, and he didn't pass away to 2013, 3 years after the study. Tim Mendham from Australian Skeptics says doctors now use this collective false memory event as an illustration of how imperfect human memory can be.
The Mandela effect has been around for a while, probably 10, 15, 20 years, something like that. It basically comes down to groupthink and group misthink. And some people have said they remembered when Nelson Mandela died in a South African prison in the 80s. And others nod their heads, say, yeah, so I can remember that. The trouble is he didn't. And he lived on for a lot longer after he came out of jail.
He went on to become president,
yeah. But people will suggest things and other people will think, yeah, that's true. And then they start to remember it. This can happen from a personal level. We probably all know a situation where someone said, oh, yeah, this happened 30 years ago. And the other person said, yeah, I remember that, yeah. And if they said, no, you weren't there. And then they say, yes, I was there. And you had this conflict about whether someone was there or not and whether their memory was real or third hand.
I seem to remember the dismissal of the Whitlam government. I remember all that very clearly, and yet I wasn't around at the time. So, but to me, it seems to be something I do recall. Yet I know I only recall it because I've seen it on TV so many times.
Many times, yeah. Yes, I remember I was there. But someone once figured out, actually, if the number of people who actually said they were at Woodstock was true, you'd have millions of people in the audience, even though some people were just saying it to be fashionable. Others were saying they probably thought they were there. But there's a lot of people who do believe, they put themselves in a position where they weren't. And one person saying it can spark a false memory and it becomes a group memory, and that fortifies the memory, and then everyone thinks they were there and they have enough information about it to convince themselves that they were actually present or they heard about some particular event or person, etc., and they become quite adamant that they were there. It's a phenomenon. It happens. It's nothing particularly limited to certain types of people.
About it. It's just what happens with memory. It tells us something about how memory works, doesn't it?
Well, that's right. Memory is very fallible, and people always think, oh, my memory is sort of perfect, etc. And even police will tell you that eyewitness accounts, especially after a period of time, are very unreliable. There's the classic case of the people throwing a ball around. It's a video. People throwing a ball around. And, they have to count how many times the ball is passed, etc., and you don't notice that there's a gorilla walking through it. And one of the questions is, did you notice the gorilla? And people say, what? Their eyewitness accounts are very poor because they're concentrating on one thing and missing something else. You go to YouTube, you can get a good version of that clip, which takes it one step further, and you'll see if you know, because now everyone knows about the gorilla. They're looking for it. This has a few steps further to see if you notice other things. And you don't, because you're concentrating on a few things. So your memory is poor. Your memory deteriorates over years. You start filling in blanks, especially when someone says something to you. And this is the problem with the false memory syndrome, which was basically people suggesting to others that they had been sexually abused or whatever in their youth. And because of the questioning that was put forward to them, they became convinced that they were. There are a lot of bad results of people sort of suffering, parents or fathers especially suffering some sort of thrown in jail in some cases because of crimes that never actually were committed. Not to say those crimes do not occur, but in some particular cases the evidence was non-existent. It was only people were persuaded to believe it.
And this is one of the big problems with using hypnotism to try and bring up old memories. It actually poisons the well.
Absolutely. People suggest things to you and then you try and cooperate. And therefore, it's the same thing happens in the psychic world. A psychic might tell you something and you think, oh, I'm not quite sure, but you want to help the psychic because you paid money for a start, and you suggest something and you agree with what they might be saying. And then you end up saying, well, wow, they knew things about me that I didn't know about me, probably because it never happened. But it's a common phenomenon. As I say, nothing particularly evil in that case, although some people might be taking advantage of it, especially in the false memory syndrome situation. But yeah, this particular one's called the Mandela effect, that one person said they knew something, even though it's false, and other people agree with them.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @Spacetime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.